Welcome to Programming in Modern C++. We are in week 4 and starting module 16. We have in the last week covered a major part of the core object oriented programming features of C++, including what is a class, what is its instance object, attributes, data members, methods or member functions, what is meant by the state of an object, encapsulation by private and public access specifiers, how to create properly designed information hiding structure by using get set idioms, various types of constructors, default, parameterized, free and so on, destructor and copy mechanism, copy constructor as well as copy assignment operator with deep and shallow copy options for pointer values. We also, based on this, we also understood the lifetime of different objects, which is very key to our design. And finally, we took a look at constness at a bitwise level, where we can have objects which are constant, or data members can be constant, member functions can be constant, and a combination of these can give you a good design in terms of the logical constness, which is further supported by the mutable feature of C++. So, we have got a foundational basis on the object oriented programming aspects. Now, we will build further on this. What I am going to discuss in this module is understanding of static data members and member functions. So, there will be extensions to the class design we have already talked of, and they will cover some specific areas of problem solving. Here is the outline, as you can see, and we will start with static data member. So, a static data member, in contrast to the data members that we have seen, which henceforth we will have to call them as non-static data members. A static data member is associated with a class, not with an object. That is the basic difference. That is, a class that I define can have multiple instances of objects created. All of them will share the same static data member. It is like a global value, but limited to that particular class only. Right? So, it will have to be, it will be declared inside the class scope, but it will be defined with its type outside the class scope to avoid linker error. And it must be, since it is defined outside the class scope, it will also have to be initialized in a source file. So, any static data member will be constructed before main starts and will be destructed after main ends. So, this is something which is very critical, that it works. It encompasses the whole lifetime of main. So, all static data members of all classes will be initialized before main starts. So, now you can see that it is like the global variables, which I said will be initialized before main and will be destructed after main. Similarly, the static data members will also be done in that way, which is a basic difference in the initialization of C++ compared to the initialization of C. A static data member, like a non-static data member, can be private or public. Now, since it is a static data member, it is not dependent on the instance of the object. So, it is possible that I can access a static data members by just using the class name, that is fully qualified class name colon the data member name, the static data member name. Alternatively, I can also access a static data member using an object, but just using object dot this member. But what compiler actually does, it does not, since it does not relate to the specific instance, From the object it will know its class and find out, internally it will find out that what is the class scope where the static data member belongs, and therefore, it will be accessed through that manner. So, virtually it eliminates, the static data members eliminates any need of global variables in an object oriented environment. After this, we will not need any other global variable which is defined outside of any function scope or any class scope. So, let us first go ahead and show you an example where there is a printer task, where there is a printer which can be loaded with paper from time to time. So, there is a tray as if that you are modeling logically by a variable which says that how much paper is there, and you can load paper into that. And there are several print jobs that are fired on this printer one after the other, and every print job has a number of specified pages, the number of pages that it has to. So, after that job is done, the number of available pages on the tray will get reduced by the number of pages required for that job. So, this is the basis of this requirement. So, we do the design like this. We have a first we show you example of simple example, and then we go to that print job. So, let us say I have this is a simple example. So, I have a class, my class, which has a non-static member x. So, I can do a get, I can do a print, right. So, if I instantiate two objects, then each object has a separate data member x in it, they are distinct, right. So, when I do get on this, basically that data member is getting set to 15. Right. So, when I do print on that, for object 1, this is this was set to 15. Now, in print this has been increased by 10. So, it will print 25. For object 2 also it will print 25, right. That is simple. Now, here on the right hand side, I have made this a static data member. The difference that I have made is I have put a keyword static before the declaration of the data member, which says it is a static data member, which means that now I have only one variable for the class, not object wise instances. I have the same get set functions. Since I have a static data member, I have to provide a definition for that. So, I provide that definition in the source file outside the scope of the class. This is my fully qualified name of the member variable, my class colon colon x. I put its type, which is int, the initialization value, which is 0. Right. Now, I again instance, I create two objects. Now, in contrast to the previous case where x was a part of the object. So, I had two different x's. Here I have x which is the same object, which is not a part of any of these objects, it is outside of that, it is just belonging to the class. So, now if I do get x, this x is set to 15, I do get on the second object, again this is reassigned again 15. So, its value is 15. Now, when I do print, the x gets incremented by 10. So, it prints 25. Then when I do print for the next time, x is 25, because it is the same x. Here I had a different x. So, 15 incremented to 25, 15 incremented to 25, but here it is the same, it is the same x. So, it is already incremented to 25. So, now what will happen? If I add 10 to it, it will become 35. So, second time it prints 35. So, this clearly tells you what is the difference between a non-static data member and a static data member. Right. So, the explanation is written below for your reference. So, with this let us go on to the print task that I just described. So, I model that there is a print job, I am creating a print job. What is a print job? print job is will print something. So, it has a number of pages which is a non-static member. Then in public I have two static data members, which is number of n tray pages, that is how many pages are there in the tray, and another is n jobs, which says how many jobs are there in the printer, right, has been put to the printer. So, with that, when I do this print jobs constructor, I set n pages, that is how many pages the job has with the parameter. I increment the static member because one more job is getting added to it, and I decrement the n tray pages by NP, because this job will print NP pages. So, the tray will be left with n tray pages minus NP number of pages. So, this is every time a job is placed, a construction is done, this will happen. And what will happen in the destruction? Naturally, when I destroy, it means that this job is over. So, now there will be one less number of job to do, right. So, it will become n jobs minus 1, right. So, with that, let us look at some of the initializations. So, this is the static initialization. So, this is the definition of n tray pages in the global qualified name, as I said, and we have initialized to 500, assuming that initially 500 pages have been loaded. N jobs similarly is initialized to 2 because there is no job to start with. So, then I initially print what is the job number of jobs and what are the number of pages, 0 and 500 is what I get. Then I create a print jobs with 10, that is 10 pages to be printed. I check these values, printing 10 jobs, it says, and it is now has jobs 1 because one job has been submitted, and the pages becomes 490 because that job submitted has 10 pages, 500 minus 10, 490 is what I get. Now, in a scope, I create 2 more jobs. Mind you, I have created a job 1 here, I have created a job 1 here, and the rule of scoping holds. So, the job 1 created inside the block scope is different from the job 1 created in the outside the block scope, right. So, the job 1 prints the printing 30 pages because it is taken as 30, job 2 printing 20 pages. Then I print what is my status of the printer. I get there are 3 jobs, print job 1 outside the block scope, job 1 inside the block scope, job 2 in the block scope, 3 jobs, and the pages remaining are 440, 490 I had, minus 30, 460, minus 20, 440 pages remaining. Now, when I before coming out, I load another 100 pages. So, after loading, when I come out of the block, what will happen? At this point, you know, you have learned the lifetime. So, print jobs, job 1 and job 2 inside the block will get destructed at this point. As they get destructed, number of jobs will decrease for each by 1. So, my jobs after this becomes 1, and the print jobs has now changed, increased with a value of 100. So, from 440 it becomes 540. So, that is how the logic goes, right. This is I wrote on top that this is not a very safe way of doing it, because these static data members are kept in public. So, besides being static, they are also exposed. So, the encapsulation, the information hiding part is not there. So, anybody can mistakenly change that, and we will have difficulties in terms of it. So, we will talk about how to handle this. Now, comes the question of what is the order of initialization. We talked about this for non-static data members, and we learned that it does not matter in which order I write the non-static data members in the initializer list, the order in which I list them in the class is the order in which they are initialized. You will be surprised to see that for static data members the rule gets different. So, here I have a class which has two data members which are static, static data 1, static data D1, static data D2, right. And in the source file I am initializing, constructing them, first D1 with obj1, then D2 with obj2, and I can see that this is the order in which the construction happens, destruction obviously in the reverse order. So, now the question is, the order that I am seeing, is it because of the order in which I have initialized them or the order in which I have listed them in the class? To check that, I just swap this, I just swap these two and do not change this. As I swap, I find that the order of construction has not changed, and so the order of destruction, but I have already swapped this. So, I conclude that it does not matter in which order I list them within the class, but it is the order in which I initialize them in the static area in the source file is what decides the order in which they will be initialized, which is different from what we saw for the non-static data member case, where the order in the initializer list does not matter, but the order in the listing of the non-static data members in the class actually dictates the order of their initialization, right. So, here this rule is different. You will slowly realize why it had to be different and what are the advantages of that, but for now just to know that when you are dealing with static data members, it is the order in which you write the initialization is the order in which they will actually be initialized and constructed. Now, let us, we have already seen that the encapsulation is broken, there is no information hiding, because if I put the static data members in public, it can be changed without the notion of the class at any point of time. If I put them in private, then I cannot change them. So, along with static data members, I also need static member functions. What are static member functions? Static member functions, the first difference is they do not have a this pointer, unlike the non-static data members, because they are not associated with any object, they are just associated with the class. So, there is no object instance whose this pointer can be or need to be passed here. They cannot be accessed, they cannot access any non-static data member or any non-static member functions. Why they can't access? Because they do not have a this pointer. The non-static data member or the non-static member function is specific to an object instance, but a static member function has no this pointer. So, it cannot. So, it is just like a global function, only difference being that it is in the class scope, it is qualified by the class name. So, it can be accessed with the class name, with the : operator, or with any member of the class, exactly the same way you could refer to a static data member, exactly in the same way you could also invoke, you can also invoke a static member function, right. So, you using this, once you have this, you can now again create the same information hiding encapsulation paradigm as we did for the non-static data members. All that you do is encapsulate static data members as private and provide the required get set idiom in terms of static member functions in public, and you can create that same model, except that now this particular encapsulation model is not specific to an object, it is specific to the class or the entire ensemble of objects that can be instantiated from a particular class. So, you may initialize static data members even before any object creation, because I told you it can potentially, it will get initialized before main starts. It is possible that you instantiate some object also before main starts, but it is not necessary. Also remember that if I have a static member function, then I cannot have another non-static member function by the same name. That is, overloading a member function between static and non-static is not allowed. Similarly, static member functions cannot be declared as const, which you will understand by now, because the consequence of declaring a member function const is to actually change the type of this pointer, which becomes now a pointer to a constant object. But since static member functions have no this pointer, there is no semantic sense of saying that a static member function is constant. It cannot be done. Now, with this improvement in the encapsulation and information hiding paradigm, let us take a relook at the print task, which remains the same, except that now I have made this in the private. I have put them before public. So, these are all private now, you cannot directly access them, and we also provide 3 static member functions. All that you need to do, you write the function as you had been doing earlier, except you put the keyword static in the beginning, which ensures that these are static functions, and therefore, they will not have any this pointer. So, this tells you this is a get set kind of. So, here what you say that you are not allowing the set on any of these. All that you are doing is you are giving get on the number of jobs and the number of trees, number of pages. If you want to set that, you have given a separate load page function, right. So, it is perfectly conforming to the get set idiom based information hiding model that we had done for the non-static data members and non-static member functions. This is same, the initialization, you create the print jobs in the same way, you do everything in the same way. Now, when you are actually trying to find out how many jobs are there and how many pages are there, instead of directly accessing the public static data member, which you could, now you invoke the public static member function. Similarly, for loading this behavior will remain the same, but now you have the safety of being encapsulated in terms of your actual static data member values. Right. So, this gives you a very nice model to work with, where any object in specific information can be kept at this level. So, we will just take a quick look at what could be potential use of that. For example, here here what we showed in terms of the printer task, if we had to do this without the static data members and static member functions, we would have required to use global variables, because the printer is one and task jobs are many, they are not specific to that. So, it is clear as to how, by using the static data member and static member functions, how we have nicely encapsulated everything within the class. I will talk about a different example. For example, say if you want to track the number of objects that you have created. Now, the question is obviously why do you need to do that? There may be several reasons for that. For example, your every object could be a lock on a port, memory port, right. You have a memory port object. Now, you have 3 memory ports. Now, naturally you cannot create 4 memory port objects, because the 4th one will not have anything to lock, right. So, lot of physical and logical situations will need that you can count the number of objects that you have created. So, how can you implement that? Could be very simple. So, I assume that there is an n obj cons which is incremented every time an object is constructed, and there is a des which is decremented every time an object is destructed. At any point of time, if you take their difference, you will get the number of objects that are live. In a simpler model, you can just make one single static data member n live, increment it in constructor, decrement it in destructor, but by doing this you will have a more informative model here. So, its example is very easy to see. I have these 2 in the private, I have the way to get Obviously, I will not have a way to set, because I cannot allow the programmer to change either the number of objects constructed or the number of objects destructed. That will have to happen either in the constructor or in the destructor. Right? I can only read them, take their difference, say how many objects are there. So, with that this example shows some objects which are created before main, and I had shown you this trick earlier also. So, I am just as if initializing a dummy integer. I am not interested in that integer. All that I am interested in is to pass it a value which initially would be 0, but actually I am not interested in that even. All that I am interested in is to invoke the static member functions even before main has started. So, I get to see how many objects are there. Then one global object gets created, then I again do that, and I get to see how many objects are there. Then I get into the main, see different objects created, destroyed, entering the scope, leaving the scope. Actually, you can you basically get a trace of the object lifetime and the count of live objects at any point of time. So, static could be of great help in terms of that. To compare static versus non-static, I have given you a complete comparative information. All of these I have already discussed in terms of what we have been learning, but this is a compiled chart which if you want to refer to, if you have a doubt as to whether can I access non-static data member from a static member function, you can look up here. No, you cannot access. Why you cannot access? There is no this pointer. But if I have a non-static data member functions, can I access static members? Yes, you can, because static members are always available by the class name, right. So, all these differences are listed here. You can make references to that, study to understand it better. Before I conclude, I will tell you a very simple design, which we will talk about separately in tutorial also. It is called a design pattern. Like this is something which repeatedly occurs in different design scenarios, and therefore, you can have a solution for this pre-designed. So, that whenever that occurs, you can just use that solution. So, it is called a Singleton pattern, that is one only pattern, which says that it is a class which ensures that only one object its kind can exist, only one object. It is funny, you have a class, you can instantiate any number of objects, you do not want that, you want only one object. And then that object, there must be a single point of access for that singular object. Right? If these two conditions are satisfied, we say that we have a singleton. Now, conceptually, what is a singleton? Something which is in the real world which is unique. For example, President of India, Prime Minister of India, Director of IIT Kharagpur, CEO of a company, and so on and so forth. The question is, how do you implement this kind of a singleton design in C++. So, two things. One is you have to make sure that you can create only one instance. Now, so you have to make sure that you cannot let anyone arbitrarily create the object. So, how can you stop creating an object? Simple ways: put the constructor in private, nobody can access it other than members in the class. Right. Now, this becomes a chicken and egg problem. If I cannot construct, I cannot have an object. If I cannot have an object, I cannot call a member function. So, how do I go about? That is where the static member function come in, because static member functions do not depend on object being constructed. So, I provide a static member function, say called printer, different from the class name, has to be because it is not a constructor, which simply will find out that do I have an instance. So, how do I know if I have an instance? So, for that I provide in the private a static pointer and initialize that pointer to null. So, what will happen when the system starts? This pointer is null, which tells me that there is no printer. Now, whoever wants calls this printer static member function, calls printer. As it calls printer, I go and check, is this pointer null? If it is null, there is no object constructed so far. If it is not null, then object has been constructed. So, if it is null, I construct an object. I do a new, construct the object and put that pointer to this and return that object. Now, if it has been constructed, that is if the pointer is not null, then I do not construct it again, I will just return the same object. So, I get both the points that were asked for in a singleton, that is, this will ensure that I can create exactly one object, not more than that, because my constructor is private. And there is a single point of access, that point of access is this static member function. Every time I need the printer, I call that member function, it gives me the same printer. First time it constructs and gives, second time onwards it just keep on giving the earlier. So, this is the basic idea of a singleton, and this is by using the static data member and by this design paradigm, that is, you put the constructor in private, you have a marker to remember that object that is in private, and you have a single point static member function to decide whether you need to construct an object or not, and return that will give you a singleton model, which here we are showing in terms of printer. It can be done similarly for any other object type. Interestingly, there is another alternate design to this, where again all that I do is in this access function for the printer, I have defined a function local printer. I am not maintaining, my constructor is private, my destructor is private, because I am not going to allow any other construction, but I am not maintaining a separate pointer as a private member. Rather, I have a local static variable in the access function, which is of the printer type. So, what happens? What is the property of local static variables? Is that they get constructed the first time the control passes through this point, and then they are remembered, because they are static, they are remembered across the calls to this function. So, the compiler does your job, what you had been doing by putting a pointer, checking that whether it is null, setting it to be not null and returning it every time. You do not have to do any of that. The compiler will take care of all of that, because that is the behavior of a static local variable of any function. So, in the access function, I simply make it static local and then I return. So, what will happen? First time I call this here, it has not been constructed, it will get constructed and remembered. Second time I call it, it will not be constructed again, because it has been, and the same object will be returned. So, it is even a simpler solution. This was originally proposed by Scott Meyers. So, often this is referred to as Meyers singleton. You can use this design, which is very simple. I mean, you do not have to remember anything. All that you need to do is to just put the constructor and destructor in private and then have the access function. So, this brings us to the conclusion of module 16, where we have introduced static data members and static member functions and discussed the use of static members in the C++ design, and particularly discussed the singleton class design pattern. Thank you very much, and we will meet in the next module.